Did you notice bright shiny shadow on the paper? And the lower arrow appears larger in size ...
Before discussing the physics enigma behind the phenomenon, it is necessary to understand some key related concepts. Case 1. Bright spot of light on paper.
Total internal reflection. This phenomenon occurs when the light rays travel from a more optically denser medium to a less optically denser medium. Total internal reflection happens when the angle of incidence, that is the angle at which the light hits the glass, is greater than the critical angle, which is determined by the refractive indice's constant value, depends on material such as the glass and air. At this point, the light is reflected back into the glass instead of passing through it. This is because the angle of refraction becomes greater than 90 degrees, which is impossible.
Consider the following situation.
A ray of light passes from a medium of glass to that of air. Light rays will be refracted at the junction separating the two media. Since it passes from a medium with a higher refractive index glass to that having a lower refractive index air, the refracted light ray bends away from the normal. At a specific angle of incidence, the incident ray of light is refracted in such a way that it passes along the surface of the glass. This particular angle of incidence is called the critical angle. Here the angle of refraction is 90 degrees. When the angle of incidence is greater than the critical angle, the incident ray is reflected back to the medium. We call this phenomenon total internal reflection. Note, while the water is present, its refractive index doesn't play a direct role in determining whether total internal reflection occurs at the glass-air boundary. Its main function is to allow the light rays to travel through the glass and reach the boundary in the first place. Working on a magnifying glass. A magnifying glass is a type of converging lens that is used to make objects appear larger. When you look through a magnifying glass, the lens focuses the light from the object onto your eye, making it appear larger and more detailed. A converging lens. It is a type of lens that causes parallel light rays to converge meet at a point. In this case, the curved surface of the glass causes the reflected light rays to converge onto the paper, creating a bright, concentrated spot of light. So, in both cases, the curved surface of the lens, whether it's a glass or a magnifying glass, acts to focus light rays, resulting in a concentrated and magnified image or spot of light.
Here's a breakdown of physical laws behind the bright, shiny spot on the paper.
1. Light source. The light source lamp torch shines on the glass. 2. Refraction. As the light enters the glass, it bends due to the change in speed. 3. Internal reflection. The angle of incidence is greater than the critical angle. The light is reflected back into the glass instead of passing through it. The shape of the shadow depends on the curvature of the glass and the position of the light source. In this case, the shadow is likely shaped like a crescent moon due to the glass's specific curvature and the light's angle. In essence, the glass acts as a converging lens, gathering and focusing the light onto a small area of the paper. This concentration of light is what causes the bright shine.
Case 2. Is the arrow actually enlarged in size?
No, the arrow will not enlarge in size. Here's what happens. 1. Light rays emanate from the arrow and travel through the air. 2. Refraction. When these light rays enter the water, they bend due to the change in speed. 3. Image formation. The bent light rays create an image of the arrow, but it's not the same size or orientation as the original. 4. Apparent size. The image you see through the water may appear slightly distorted or magnified, but it's not because the arrow itself has changed size. The size of the arrow remains the same. It's the way the light rays are bent that creates the illusion of a different size or orientation. The lower arrow appears larger in the image due to refraction. The light rays from the lower arrow pass through the air and then enter the water. Because water is denser than air, the light rays bend as they enter the water. This bending is called refraction. The specific way the light rays bend depends on the angle at which they enter the water. In this case, the angle is such that the light rays come together as they pass through the water. This convergence makes the lower arrow appear larger than it actually is. This phenomenon is similar to how a magnifying glass works. The curved surface of a magnifying glass causes light rays to converge, making objects appear larger. In the case of the glass of water, the water itself acts as a lens, causing the lower arrow to appear enlarged.
Hope your concept of internal reflection and some other terminologies have been cleared till now, and we'll meet again with another interesting physics enigma. Stay tuned, stay blessed.